Hello and welcome back everyone to another episode of Indexer Office Hours. Today is the 16th of August and this is IOH 72. If you're new to Indexer Office Hours, we love participation, and so when it comes time to the open discussion, please do raise your hand, unmute your mic and share your opinions, or if you feel more comfortable, feel free to write in the text box to the top left-hand corner. Just remember that this will be recorded and posted onto YouTube, so if you want to keep your identity unknown, please bear that in mind. So, I am looking forward to discussing today's GRTIQ episode. It was with Alejandro, who is the product strategist at 𝗨𝗨𝗀𝗀𝗀, if that's how you pronounce it correctly, and also the co-founder of the Open Money Initiative, which is a qualitative research firm that explores how money is used in collapsing monetary systems, specifically focused on Venezuela. And so this conversation was quite interesting because it spanned across the two areas of work that Alejandro is involved with. The first one, which is 𝗨𝗨𝗀𝗀𝗀, if I didn't mention it, it is an e-commerce platform where you can effectively buy gift cards so that you can use your crypto in everyday purchases, which kind of makes the use of crypto more manageable. And then he also speaks a bit about the fact that an open financial system is a human right, and the conversation went into the Venezuelan economy and how they use money there. He spoke a bit about his Web 2 career and how he moved into Web 3, his views for digital currencies and how that could impact the world. And so I found it a very interesting conversation that merged the two worlds together. So if you haven't checked out the episode, I'd highly recommend doing so. So with that, I will hand it over to Anna to take us into Repo Watch.
Thank you, Abel. Hello, everyone, and welcome again to the regular Repo Watch segment. Just a reminder, the agenda has been posted, and I will only be mentioning the clients that have had a new release this week. If you want to check the previous releases for the rest of the clients, please check the agenda. And with that, let's go into it. So on Streaming Fast Get, we have had a few new releases. So we have had two new releases for Get version 1.10.21 for Firehose 2.2 and 2.1. We have had a BSC release version 1.1.12, Firehose version 2.1, and a Polygon version 0 to 16, Firehose version 2.2. That's all we've had for the major blockchain clients this week. And on the Graph Stack, we have no new releases, but on the Indexer service and agent, last week we talked about version 0.20.1, and during IOH, version 0.20.2 was released as well. That was briefly mentioned last week, so I've included it in this week's episode. So the update on that release was just a fix to create database migration to expand failure reason column. So before I hand over to Protocol Watch, does anyone want to share any experiences with any of the new releases, either on the major blockchain clients or on the Graph Stack? I can.
It's a little tough to hear you.
So I was just asking if anyone wants to share any experiences with the new releases, if you have tested them in your environment.
Can you guys hear me now?
Yep.
Yeah.
Sorry about that. Yeah, we've just been testing the new Aragon version in our production environment. Works great. No issues to report.
Thank you.
I'll also just note that I think maybe yesterday, or at least in the last couple of days, there was an update to networks.md to indicate that 0.27.0 of GraphNode is the recommended release for production. So yeah, everybody should upgrade. We've been running 0.27.0 in production for a while and had no issues.
Thank you, Chris. And Kai, just to double check on that, are you talking about the Aragon release that was released 16 minutes ago?
No, I just saw that hit the airwaves. We'll be compiling and upgrading today then.
Okay, so then you're talking about release 2022-0801 from last week.
Yeah, that's right.
Okay, well, since this happened just now, we do have a new Aragon release, 2022-0802, and some of the changes are disabled state cache in the RPC daemon to improve performance of queries, various fixes for various bugs, and an added terminal total difficulty for Ethereum mainnet. I won't ask anyone if you've tried it because it's 17 minutes fresh. So I will hand over to Juan for Protocol Watch.
Thanks, Anna. Okay, let's get into Protocol Watch. For forum governance, we have two new, well, not new, but two updates. One is a new thread, which is called Chain Identification and Aliasing for the Graph Protocol. This is a new GIP that basically tries to settle the naming conventions for all of the chains so that the network now will start using CAIP2 compatible network names instead of the aliases that we've been using for so long for the subgraph manifest, like Ethereum mainnet, 𝗨𝗀𝗀𝗃𝗵, yada yada yada. It would be greatly appreciated to have like input if someone has some input regarding that. I know there's a discussion regarding forks and stuff, but yeah, that's about it for it. GIP 27, altruistic allocations and stale allocations, has been executed by the console, and now indexers can, if they choose to, open altruistic allocations that cannot be closed by external agents, as far as I can recall. So those are the 0GRT allocations. Regarding forum research, there's no new updates since last OH. Contracts repository, there are a few open PRs and closed PRs since the last time we checked. Most of them are just improvements like bumping versions of some of the packages that the contracts repository was using. Also some improvements in the configuration files, a few refactors here and there. Most of it is related to the work regarding L2 scaling. So yeah, that's about it. Network subgraphs, there's also no new releases since last IOH, and that's about it for Protocol Watch. I'll hand it over to 𝗨𝗀𝗂 now.
Thank you. So, as part of today's open discussion, we have two sections. The first is Derek from Data Nexus, who's going to share a trick with his Grafana dashboards that's helped him improve his operations and quality of life as an indexer. And then the second part is Alexei, who's going to be demoing how to operate 𝗨𝗨𝗃𝗀𝗃. And for anyone who hasn't already seen the YouTube show that we've done for 𝗨𝗨𝗃𝗀𝗃, I will post a link very shortly in the chat. But without further ado, I'm going to hand it over to Derek, who's going to share some tidbits with us, which I'm very much looking forward to sharing with the rest of the community.
Thanks, 𝗨𝗨𝗃. Yeah, so this initially sparked kind of from, I guess, our role as a curator in the network. There's been this, constant question of, how many pending query fees do you have? And I talked to some indexers who have figured out a way to calculate this, and then I've heard from a lot of indexers that they just don't have eyes on this at all. So we dove into the database and put something together that we can share. So I'm going to share my screen. And let me know when you guys can see that.
Yep, we can see it.
Okay, great. So we started to go into the agent, and basically we built a query that will essentially provide this, which will show you the status of your allocation, what the allocation ID is, the IPFS hash for the subgraph, how many tokens you've allocated to it, and then the pending query fees on that specific allocation. It grabs this data from the agent DB, So we'll go to Postgres for a second. And it just looks at allocation summaries and allocation receipts and just sums the fees inside of there. When we were first running this, it didn't give us quite as much data as we would like to have had. We limited it to just the active allocations by looking where the closed at is null. So the allocation has not yet been closed. And then that gives us an output that looks like this, but it doesn't, we then have to take the allocation ID, go check out graph scan or or something else in order to see what subgraph that's correlated to, because the deployment hash doesn't actually exist inside this table. So we then started to index the graph network subgraph, which will obviously appear in your graph node. I don't know if you guys can see this or if it's too scrunched down. But by indexing that, we could then join the allocation ID to get the deployment hash and all that other good stuff. And so we put this query together, which I will share in the chat, that you guys can easily just plug into your Grafana to get this nice dashboard. It'll show you all of your active allocations, so that you can kind of watch numbers go up, which is always fun. And then it'll also show you the closed allocations for uncollected, or it'll show you closed and uncollected allocations from within the last 7 epochs. So as soon as something goes past that 7 epoch mark and that it can no longer receive new redemptions, it'll automatically fall off this list. And that way you can also have eyes on allocations that the agent didn't push through, and you can kind of see like, okay, well, maybe we want to manually push this one through or whatever. Or you'll notice like, hey, this one's really high. What happened? Oh my God, I set my threshold too high or whatever. But by adding the eyes on it, I feel like we can get more control over it. So I will post that in the chat. One specific thing is that in order to cross query multiple databases, we turned on DB Link, which I will include inside the query. There's a very simple extension that you can add in to just create extension DB Link. And then for the query itself, you'll obviously have a different schema name. So yours won't be SGD161, or very likely will not be that. You'll need to swap that out, and then also swap out your database name for whatever your graph agent database is. So I'll post this one in the chat, as well as the one that is not also indexing the graph network, and it's just showing you the allocation ID and then a prettified view of the fees. And you guys can use whichever one you would like. And with that, I don't know if it's appropriate for me to ask any questions. All in all, it's a relatively easy thing, but I'm always available for questions offline if you guys need anything from me. But with that, I'll pass it back over to Abel.
Amazing. If you want, we can do a little bit of Q&A here. If not, we can always, like you say, touch base offline. It's up to you. What do you prefer?
Yeah, if there's any immediate questions, I'm happy to help answer those now.
All right. Well, we'll open it up to everyone. So if you have any questions, please do shout or write in the comment box.
Yeah, just looking for those queries. That looks pretty sweet.
Ooh, that was a great suggestion. Chris, do you want to elaborate on that?
Sure. Yeah, I mean, this is kind of the first way that has been published for indexers to get a view of query fees that they have basically collected but haven't yet collected, as in they've got receipts for, but they haven't collected the voucher for yet. So yeah, this is yeah, an awesome contribution to the ecosystem. Thanks, Derek. Moving forward, I guess we don't want the user experience of needing to like customize that query name or the schema name in the query. Ideally that's something that's kind of just handled for the indexer. At least one of the ways I think we could do that was, just export, like the indexer agent and indexer service obviously already export a number of metrics via their Prometheus interfaces. So it would be fairly straightforward, I think, for the agent to, effectively run that query that Derek has provided. Maybe, resolve, like do some of those resolutions instead of in SQL, just execute queries against GraphNode. Obviously, you can do that because it's inside indexer agent and not inside Grafana SQL, which, I think that's probably the only way to have done that. Never actually seen that DB link stuff before, so learned something. Thanks. But yeah, we'd basically just have indexer agent monitor those metrics, the uncollected fees for each allocation, and then export them as a metric that you could graph or chart or view, alongside all of the other data that it exposes.
Yeah, a couple of points on that topic too. One, it would be helpful if the IPFS hash was located inside the allocation summary table. That would obviously help join things quite a bit. Separate thought towards what you were saying. One thing that we've started to see is, because we have in our Grafana dashboard the number of queries, and that's pretty easy to see. But different consumers can also set, their maximum price. So someone might just be using the default, and someone might, try to undercut that default price or whatever. And so we've started to notice some variances, but being able to have eyes on this early from our indexer side has been super useful.
So I also posted in the chat some work that is related to this that Alexi's done. This is a good segue maybe into the next segment. In preparing the 𝗨𝗀𝗧𝗧 tool, he added some detailed query logging to the indexer service. So you can turn that on with the flag, and it'll log like query times as well as fees collected for each query out to your logs. And then it would be nice to add a metric for that as well.
Yeah, well, that's a great segue. So without further ado, Alexi, I'd like to invite you to stage to take us into the journey of 𝗨𝗀𝗧𝗧.
Hey everyone. So I wanted to talk today about mainly how to deploy 𝗨𝗀𝗧𝗧 and how to use it, and then we can have open discussion about that. But yeah, I'm not gonna go into the details of how it works because that's covered in the video that was posted a few minutes ago and in the chat. We recorded that during Graph Day. There it is again. So yeah. So I'm gonna share my screen just a sec. There you go. Can you see my screen?
Yep,
We can.
indeed.
Yep. So this is just a schematic of what's going on. The idea is that we have a special, we have wrapped the indexer service. So you got the queries coming from the gateway. They go through the indexer service, and that the blue box, the 𝗨𝗀𝗧𝗧 indexer service that's surrounding it, that's tasked with filtering the logs. So that pull request that Ford just posted is about us getting the logs we need to compute the statistics for 𝗨𝗀𝗧𝗧 to function. So yeah, so we're filtering the logs, we're getting those special logs, and we send them to what we call an 𝗨𝗀𝗧𝗧 processor, also another component, and that is tasked of extracting all the information from the log lines, normalizing the GraphQL queries, because there's many ways of writing the same GraphQL queries, as you may know. And all of that normalized, cleaned up data gets dumped into a Postgres DB, where we have two things. So we have what we call the query skeletons. So that's pretty much the normalized query without any of the concrete values in there, with all the variables removed. Because we did notice by looking at statistics of queries we're severing that most of the there is queries that repeat a lot and only values change. So we can compress data that way, and we can also identify costs more easily that way. So we have query skeletons, which is that deduplicated list of normalized queries, and then query logs, which is like proper logs, right? So every time you get a query, you get a new entry, and it's referencing its query skeleton, and it also contains the variable values to fill in, so you can reconstruct all of your logs that way. But yeah, the important thing there is that things get normalized, so it's not as it's not the same when you just collect the logs from GraphNode like you would normally. Here, things are normalized, they're put into a DB, they're easy to, and it's easier to compute statistics then, right, on what you got in your DB. So, and then we have the main piece, which we call just 𝗨𝗀𝗃𝗀, which gets query metrics from the indexer service. So that's to determine how many queries per second we're getting for each subgraph. And it's also using the statistics of the historical queries we've seen to determine how some query skeletons, let's say how expensive it is to run some query skeletons compared to others. So we have two aspects. So that's covered in the video, where 𝗨𝗃𝗃𝗀 will set for each subgraph the relative cost of those query skeletons, and then all of those query skeletons prices are multiplied by what we call a cost multiplier. That cost multiplier is what we use to follow the market price. That's mainly using the query metrics to determine the cost multiplier. Once again, I'm going fast, but it's all in the video. Anyway, so that 𝗨𝗃𝗃𝗀 is pushing Agora models plus the cost multiplier as an Agora variable to the indexer agent, and it's also spitting out some of that AI agent parameters, and also revenue metrics that we got from the query logs to Prometheus, such that you can then watch what's going on live. So after this, I'm just going to show you the repos, because there's a little bit more details, a little bit more concrete as to what settings you gotta use for this guy. I guess it's also a good time for you to interrupt me if you want to have some more details, for some of those pieces.
One quick question: are the query skeletons, is that done at a subgraph level, or is that at a network level?
It's per subgraph, because it's not cleaned up in such a way that it's subgraph agnostic, right? It's really just you take your query and you just remove all the values you see in there, and you set them as variables, and then you just store that, and that's your query skeleton. So it would be different for most subgraphs. And the goal here really is to compress your logs and also quickly determine, if I see that skeleton many times, then 𝗨𝗃𝗃𝗀 will go back in there and say, okay, well, now I'm going to look at my logs for that very query skeleton, and I'm going to compute the mean execution time that I've observed on my own, historically on my own stack, and then use that to set a relative cost, right, of running that query skeleton. So it's a bit rough, but it's better than nothing, right? we can indeed improve that method further down the line. Okay, so I'm gonna show the repos. Yeah, can you see that?
Yep, we can indeed.
Yeah, so for now we're on GitLab, and so it's GitLab /semiotic-ai/the-graph/𝗨𝗂𝗧. There should be links somewhere, I guess. I can post that. Anyway, yeah, so my shortcut for the microphone is also for zooming in and out of Brave, which is great. Yeah, so the idea here, so first there's a warning. So just want to reiterate that this is still very experimental, and I'd prefer if only very experienced indexers that are watching the numbers all the time try this, because if it misbehaves, just turn it off and maybe send me a message. But yeah, it's not yet for let's say hands-off indexers. Yeah, if you're a hands-off indexer, don't do that. But yeah, the idea is that it's container-based. On that page, you got the links for the 𝗨𝗂𝗧𝗧 indexer service, which is wrapping the actual indexer service, and the 𝗨𝗂𝗧𝗧 processor. And there's a little explanation as what it does. We've been using this mainly in Kubernetes. I wouldn't know how to run and build those things outside of containers, because maybe it's possible that dependency management will be a problem, but it's up to you. In any case, as you may have guessed from the schematics, we need to give 𝗨𝗂𝗧𝗧 needs to be able to talk to the indexer agent management endpoint. So that's to determine which subgraphs we're allocated to. The indexer service metrics, so that's to get the number of queries per second. We need access to read from the Postgres instance that contains those special 𝗨𝗂𝗧𝗧 logs. Up to you if you want to use the same Postgres instance as for the rest of your indexer stack. For now, I wouldn't advise that. It shouldn't be a problem because you can specify which database you want to use, but up to you. If you feel like doing risky things, up to you. We have a refresh interval for rebuilding the relative costs of query skeletons for a Agora model. The default is 1 hour. That experimental model builder is the actual. So if you turn that on, you get those query skeleton relative costs. If you don't turn it on, then you just get a flat price with the cost multiplier. So it's up to you if you want to have that fancy relative costing, or if you don't care and you just want to have a flat pricing that follows the market price. And another important thing, especially at this stage where it's quite experimental, is that 𝗨𝗂𝗧𝗧 exposes metrics on Prometheus on port 8000. And I really, really recommend that you build a Grafana dashboard for this, such that you can follow what's going on. And, if you don't like it, turn it off. So that's pretty much it about this guy. Do you have any questions?
I have a question.
Oh, sorry. Go ahead.
Thanks, Payne. With experimental model builder off, it will, basically just have a cost model that sets the price to the price multiplier, which is supplied as a variable.
Yes.
So, if the price multiplier is kind of the core behavior, how does the how do the models kind of weight the price against the multiplier, if that makes sense? Like, how does the measured cost of a query impact the price that comes out, relative to the price multiplier? I don't know if that made sense.
Yeah. Well, right now it's a pretty simple system where we put the query skeleton directly into Agora, and we set it as the price as equal to the average execution time in milliseconds times price multiplier, and that's it. So for each query skeleton, you'll have a different average execution time. So for each skeleton, you'll get, let's say skeleton 1 will be, the price will be 32 times price multiplier, and then skeleton 2 will be 15 times price multiplier. And then we just adjust that price multiplier every 2 to 3 minutes as we're training.
And I guess the behavior of the price multiplier will be dependent upon other variables in the model. So the multiplier will self-correct for the presence of the average query milliseconds. Am I thinking about that right?
Well, the price multiplier is not really concerned with those query skeleton prices. What it's doing is
by virtue of having a feedback loop with the gateway that is, it would kind of account for them, right?
Yes, indeed. And the way it works is that it's basically just looking for the subgraph as a whole for the price multiplier. And you know how, if you set your price very low, you get a high number of queries per second, and then you can increase your price and it's kind of flat, and then there is a drop off, right? And there is a sweet spot in the middle, right, where you want your price multiplier to be set where you get the maximum bang for your buck, basically, right? Yeah, that's the market price. And so, indeed, depending on those relative query skeleton costs, then the price multiplier will be different.
Yeah. Okay, cool. That makes total sense. And then it would be fair to say then that if you have the experimental model builder on, you would be more competitive for queries where the average execution cost, or where the execution cost is below the average, but less competitive where it is above the average.
Yes. And the idea there, the concept was that we want consumers to pay for their harder queries, and if they don't like it, they should build more efficient queries.
Makes total sense. Thanks, Alexi.
Yep. Yeah. So that's the main piece, right? That was the 𝗨𝗀𝗧𝗏 blog, the main piece, and we can now move on to the other components. So we have the 𝗨𝗀𝗧𝗏 processor, same thing. It's Docker based, and this guy needs to talk to the database because it's writing those logs. It also needs access to the GraphNode query endpoint, and that's to be able to pull the subgraph schemas, because it uses the schemas to normalize the queries. It needs to be able to read from RabbitMQ, because that's what we used as the exchange for the logs. And yeah, access to Postgres to write in there. So that's pretty much that. And the 𝗨𝗧𝗏𝗧𝗏 indexer service, I have no idea, by the way, why the background is white. Anyway, here, what it does, so it doesn't do much in case you're worried that it's going to mess with your indexer service. It's a little Go program that is charged of running the actual indexer service, reads the logs and filters them. It keeps the query timing logs for itself, sends and forwards them to RabbitMQ, such that then downstream 𝗨𝗲𝗂𝗧 processor can process them, and then spits out the other logs back to standard output, such that you get your usual logs in the same place as before, or at least if you were running with Kubernetes, right? Well, I guess in all cases. And so it just needs to talk to RabbitMQ. That's pretty much it. So indeed, you'll have to also, of course, add a RabbitMQ instance in your stack, but that's pretty light. And in particular here, this guy depends on a special branch of Indexer service where I backported the pull request number 428 back to Indexer service version 0.19.3, so that so that you don't need to go with a pre-release of Indexer service. So you just run make on this guy, and it's going to build the Indexer service, the special Indexer service version 0.19.3, and then the wrapper around it, and you'll get your container. You can just run it. Yeah, I'm sharing again this just to give back the context. Do you have any questions or comments up to here? It may have been a little bit dense. I'm sorry for that, but trying my best.
No, we appreciate the detail. So thank you so much. Yeah, if anyone has any questions, please do share.
I do have a question. I'm not sure if this was already answered, but because I wasn't paying attention earlier. But will the 𝗨𝗂𝗧 Indexer service actually make it into the official Indexer service repo, basically? Or will it always require a separate instance?
Well, my view for now, though, is that it should remain separate because it's doing something different than what the Indexer service is expected to do, right? I mean, in terms of sending sending certain logs to RabbitMQ, and I strongly believe in separation of concerns, right? I'm a Unix guy, so I think it's better that way. And for now, indeed, it depends on that weird, that special build of Indexer service. But down the road, it's not. It's just gonna pull the official Docker container from Indexer service. So starting with version 0.20.1, I believe, and it will not mess with any of the Indexer service code.
So it's basically just pulling the latest release and then iterating on top of it, right?
Yeah.
As in, you don't have to maintain an upstream or anything like that. It's automatically doing that in the background.
Yeah, you can do that. So right now, what's going on is that I expect. So you can see here the Docker file. I expect that I have that special build of Indexer service available, but down the road, this is going to point directly to the GitHub container repo, Indexer service 0.20.1, and then just add my stuff on top, and that's it.
Okay, got it. So do you have a rough timeline for when that's going to happen?
So the 0.20.1 is already out as a pre-release.
Oh yeah, it is indeed pre-released. Yeah. So can I just change that line in there to 0.20.1 and just have it running?
Yep.
Like that?
Yep.
Okay.
You can also just obviously if you're already running 0.20.1, then you because migrations have happened, you still want to run it. But I don't know, Alexi, I would guess that the existing GCR reference there is a public repo and anyone could just run make and it would just work. They don't have to think about anything.
Well, no, it's not a public one. And by the way, I should probably change that line in there. It just escaped from my own setup, I guess. But if you run make, it will locally Huh. No, I guess it's gonna. Yeah, I have to fix it, I guess. Well, it's good, right? When we explain to other people, you see your bugs and you figure out new things. I guess that's the case here. But yeah, this is wrong. This should point to something else. Yeah. But yeah, I expect for now that people will build it locally. Remember that it's still experimental, right? So I don't expect that it's going to be as smooth as butter. I guess that will also filter for the more experienced people, right? Because yeah, if everybody runs 𝗨𝗀𝗳𝗂𝗧 willy-nilly and there's problems, that could cause issues, right, with the network, perhaps, maybe. So yeah, just be careful and report to me your findings and comments. Yeah, just to add, by the way, 𝗨𝗀𝗳𝗂𝗧 indexer service, it creates that container, but it's meant to be a drop-in replacement for indexer service. As long as you keep on. Yes, Chris is right. Listen to Chris. And yeah, what was I saying? Yeah, it's classic Unix joke. 𝗨𝗀𝗳𝗂𝗧 indexer service is supposed to be a drop-in replacement for the indexer service. So as long as you send all your indexer service settings through environment variables, it's going to work just like before. Yeah, you shouldn't see any difference, except that now it also talks to RabbitMQ. That's it.
All right, sounds good. Thank you so much. Chris, by the way, last time I made that joke during mission control, Zach got really mad at me.
I think it's a good filter. It really works.
It does.
It's like a driver's license trick question.
Lol.
So, Alexis, besides the one container that seems to be referring to our indexer, are there any other build tools or anything that indexers are going to need to know about in order to build this, besides like Docker?
You should only need Docker. I made it such that only Docker is required. Well, I guess there's a make file, so if you don't want to run things, type Docker commands by hand and you run the make file, you'll need make also. But yeah, everything should be Docker.
Also, do you want to share some of the performance numbers that we've seen as far as any impacts to query answering time or revenue changes?
Oh yeah, so yeah, I forgot that I had those guys too. Okay, so Grafana boards, and what we're looking at here is okay. So I'm just actually, so I'm going to show promising plots, and I'm also going to explain the caveats, right? Okay, so here we have a nice example where we have one subgraph. So this GU, I believe, is UMA. So here we have the number of queries per second. Here we have the GRT per second. I have a doubt about those numbers. They seem to be scaled weirdly, and I'm literally taking just the numbers from the the receipts. But as long as it's proportional to the actual amount of GRT we're making, I guess that's okay. And here we can see, so what we call bandit is actually the name of the particular reinforcement learning agent that we're using. For those that are machine learning inclined, we're using a continuum bandit. And this model basically is just here a Gaussian that's modeling probability distribution over price multipliers. And we're sampling that distribution to apply the prices and also to get information as to where we are in terms of the revenue per second curve, right? Because we want to be at the top of that curve. And So yeah, we have a mean and a standard deviation. The units are a little bit weird, especially for the standard deviation. The unit is different, but it's still good to monitor. In any case, we see the mean here, and we see how over time the mean changed, went down because it had to lower the price, and then it went up. And we can see that in the GRT per second, we're almost steadily going up, right? I believe there was some kind of market change around, that morning. That was specific time. But yeah, that's pretty much what you get, right? And you expect the GRT per second to hopefully be optimal. Yeah.
Would you be kind enough to share this Grafana dashboard?
Sure. It's just that I don't expect it to work. If you drop it into your setup, it may not work, and you may have to change some sources. But yeah,
exactly.
I can do that. I can add it as an example, and 𝗨𝗂𝗧𝗏 repo. I guess I should do that. I wasn't sure if it's really applicable because everybody has a different setup and it may not work. But
it would be very easy to modify. Then you have the baseline, and you just need to change the sources, I guess.
Mm-hmm. But yeah, overall, how you read this, you can see that when the bandit standard deviation was higher, the sampled values were a bit wide, so it's sampling up and down as it's training, and it takes a lot of time, sadly, because we're limited by how fast the gateway updates its model. But it's exploring, as Chris says, exactly, and it just narrows down. It's converging, so it took like 12-ish hours to maybe 6 hours to be nice, right? And then it continues to converge a little bit. But you can still see the mean moving around, right? So the fact that it converged doesn't mean that it's just stopping to explore and it decided on a price and it's not moving anymore, right? It will continuously move around. And if the price changes suddenly, then the standard deviation will go up again because it will explore larger, and then it will eventually narrow down again onto the optimal money per second zone, right? Here it's the reward. So you can see basically the reward is the number that's used by the reinforcement learning to steer the reinforcement learning, right? So of course you want to optimize for highest possible reward. And you can see that the reward goes up steadily, kind of like the GRT per second subgraph. These are somewhat related, of course. Really, the reward here is queries per second times price multiplier. You want that value to be as high as possible. Any questions here?
Yeah, so as far as the sampling rate, you said that it was super slow, and I think we've discussed this in the office. It's been like 2 minutes. What would you recommend as far as, is there any way to get around that, or any changes to the gateway that could improve this or improve the dynamics?
So there was a recent change in the gateway already that lowered the sampling time from 2 minutes to 30 seconds. And so we can indeed go a little bit faster that way. And I've included that change in 𝗨𝗂𝗧𝗏. I lowered first to 30 seconds, and I saw some instabilities, so I increased it back to 1 minute, but it's still better than 2 minutes as it was before. But yeah, we're limited by that mainly. And one of the complexities of this is that there's multiple gateways, and they all sample at different times, but they all sample, well, now it's every 30 seconds. So you can't really, there is no really guessing that you can do for now as to, when is your new price really applied? Because you may have been queried by one gateway, but maybe other gateways still haven't updated your new price. So you gotta wait for now. That's the only way. In an ideal world, I guess you would push your price and it would immediately apply. Though I don't know if there's some technical limitations to that, or maybe DOS risks. So yeah, that's kind of outside of my knowledge here.
Just want to comment on that. Chris, this may be an application that could be solved by the gossip network if, assuming that we can get that up and running, tie the gateways into that.
Yeah, I think that's definitely on the list of cases, though the intention is to keep the gossip network kind of entirely extra protocol for a while, just to give us the, I guess, the safety to, play around and innovate in that layer without kind of, more systemic risk being introduced. But yeah, certainly like gossip as a facilitating cross-indexer signaling some kind. Yeah, it's an obvious use case. Definitely agree there.
Yeah, and one of the applications, even though it sounds counterintuitive, but our resident reinforcement learning expert Annie, who's been mainly working on the allocation optimizer, suggested that we could have indexers share a lot of information. For example, indexers could share what prices they chose, or indexers could even quote unquote agree to a price in a way that's still competitive, even when indexers are untrusted. So there is some game theory behind that, and that could perhaps help with converging faster to a solution. I don't know the details of that because I'm not a reinforcement learning expert, but yeah, that could be a future investigation with the gossip network.
Awesome. One question I had, Alexi. So we've discussed this, and like I've played with this kind of thing, this kind of technology before, but in my own very dumb and way. And as we'd spoken about, the way that I had approached it was polynomial regression over the revenue stream data to create that price revenue curve. And my kind of naive assumption was that the shape of the price revenue curve should look like a second order polynomial. And I still kind of intuitively think that that's true. So I was wondering if you think that that's the case. And then I was playing with this. Something that I managed to do is like you can get a Grafana plugin to embed one of these more powerful JavaScript visualization libraries, and that used that to actually visualize the shape of that price revenue curve. And yeah, I was wondering what you thought about that. And like I would presume that with this method you can approximate the price revenue curve as an equation, right?
Yes. In a very indirect way, the optimizer here kind of does that, right? And you'd be right, yes, that it's a second order curve. But the idea here was that we wanted an algorithm that's capable of balancing the exploration and what we call the balance between exploration and exploitation in reinforcement learning, where when you have a good solution, ideally, if that solution doesn't change, you would just use that number. Like for example, here I could just converge to one number and then only use that number forever. That would be the optimal thing if the price doesn't change, right? Whereas here, it's a little bit suboptimal because I'm constantly sampling around the optimal version, as you can see in the bandit sampled price multiplier. But the goal of this is that you always have an image of the shape, even if it's extremely local. And using that shape, you know if you're at the top or not of that second order curve. And if it ever moves, then you can quickly just sample larger and then once again find that optimal point. So yeah, that's why we chose that solution.
Thank you. Do you think that like visualizing the curve really matters much?
Probably for debugging and maybe to reassure the indexer that things are going okay. The curve should be pretty easy to plot though, because it's basically an XY curve. You just plot your your price multiplier versus your let's say revenue, and you should see at least a piece of that curve. And because it's sampling around the optimal point all the time, you should see at least a little bit. You should see ideally just the top of that second order curve, right?
That makes sense.
Maybe I should try that visualization indeed. That sounds pretty cool.
Yeah, let me see. I'll find that Grafana plugin and send it to you.
Yeah, so I'm just gonna give 2 caveats because not everything is perfect in life. So one problem we encountered was with subgraphs that had very low or 0 queries per second, and the problem there was that the optimizer would just, because it doesn't find any reward, it just enlarges the Gaussian, so increases the standard deviation forever and ever and ever, and it never recovers from that. So that was a big problem for us. In a way, because our reinforcement learning agent is pretty simplistic, which is good for interpretability, right? It is rational behavior, right? It's like you don't know where to go. You're in a dark room and you don't feel anything. You just run everywhere. You don't know where to go. So it just increases standard deviation and then cannot recover. So we implemented a solution that kind of like disincentivizes the increasing the standard deviation very high, and especially basically we added the quote unquote a little force that if there is no reward, then that little force kind of takes over and brings the Gaussian back to a homing value that's reasonable. So for now it's set to a price multiplier of 10 to the power minus 6 and a standard deviation of about 2 point something. And the problem with that, though, is that now convergence is less sharp, as you can see in those plots here, even on subgraphs that have a good number of queries per second. So the price multipliers are noisier. And you can see it also here, the GRT per second per subgraph. So that's stuff we're working on still. So yeah, now things don't explode anymore, or not as much, but yeah, convergence is not as great. Caveats. That's all I have.
Sweet. We have 2 questions in the chat, one from Derek and one from Chris. So if you'd like to go ahead and check out the chat and answer them, that'd be great, just as we wrap up.
So Derek's question is, do I see basically the effect of other indexers opening and closing allocations? I haven't looked for that, but that's a good idea, and it should indeed influence, yes. But I haven't looked for this in particular. I've been mainly busy with stability and convergence for now, so yeah. And what's the other question?
That was from me. Just whether that kind of tiny force can be made relative to, I guess, the confidence level that you have in the data stream. So like the higher the QPS level, the more confident you can be about the signal, and therefore the less you need to leverage the force.
In a way, it's kind of like how it works, because the reward values will be higher if you have a higher QPS and you can reach higher multiplier values, while let's say the inverse reward of increasing standard deviation and moving the mean outside of the the homing value would be kind of like always the same order of magnitude. So I expect some effect like this, but I think I'm going to look for a better solution because I'm not super happy about that plot I'm showing here.
That makes sense. Thanks, Alexei.
Yep.
Wonderful. It looks like we're just over the top of the hour, so I'm going to take this opportunity to thank Aleksey for taking us through all of that, and to Derek and many others who contributed to today's conversation. Thank you all, and with that, I will bid you farewell and look forward to seeing you all next week. Take care, everyone. Bye-bye.
Thanks.
Bye, everyone.
See you guys. Thank you.
Bye, everyone. Thanks.